Especially when working in a professional environment, one often has to deal with legacy code. And here the requirements for your software can change, new features have to be implemented and so on. After some time, code that initially was well designed can start to become a mess. This is when you normally will try to refactor it. For already purely functional code, this is quite easy in many cases, as we will see later. But first, let's have a look at how you can mix functional programming with object-oriented programming. Say you have the following typical structure. There is a base class and some derived classes. At one point in your code, you have a sequence of base pointers pointing to derived objects of different types. In your old code, you perhaps would now have a part that for loops over the pointers to do something with them. But to improve readability, you want to rewrite this in a functional way. Luckily, you can now operate on pointers in a functional way as usual thanks to std_memfun. It converts a member function into a callable object that you can pass around like you now are used to do. The callable returned by memfun has some additional nice features. It not only has an overload for shared pointers, but also for normal pointers and simple objects, so it's quite versatile. If you want to call member functions of objects in a sequence that change the state of the objects or have other side effects, I recommend using a range-based for loop though. Code with f+transform or alike suggests that something pure is going on, and one should stick to this convention for clarity. There can even be different layers of object-oriented programming and functional programming. The inside of a member function of a class can be implemented functionally. The object again is used in typical OOP style, but at some point you process it functionally, perhaps again inside a layer of OOP structure and so on. Like alternating Matryoshka dolls. So the two paradigms can complement each other quite well if combined cleanly. But the real joy begins if you refactor code that was designed functionally from the beginning. Say you have a keepif with an inline lambda that grew a bit too large over time. You can simply factor it out to a global function with cut and paste, and then give it a meaningful name. Since you of course wrote your lambda as a pure function, you cannot break anything with this approach. Rearranging expressions like this is simply an equivalent transformation. To make this especially easy, you should keep the capture list of your lambdas as short as possible, or at least capture every variable explicitly instead of using capture all notation. Of course, there are more complex situations in real life, but the general rule is that code without side effects is extremely easy to refactor compared to code with much side effects, since you do not have to care about order of execution and all this. This is why you should try to concentrate the side effects in small isolated areas of the code and keep everything else pure. As an exercise for you, I suggest you look through some old code you wrote or are maintaining. See if you can express unnecessary complicated source lines better by applying functional thinking. If you do not want to introduce functional plus as a dependency into this project, have a look at the headers algorithm and functional from the STL.